Suppose that 50.32 grams of a metal nitride, M3N5, okay, so we don't know what M is, we know N is nitrogen, reacts with hydrogen to produce the metal and NH3. So we need to balance the equation so we understand what's going on here. So if you balance it, and I'm not going to go through the process, but this is 2 of this compound, that would be 15 hydrogens, 6 atoms of our metal, or 6 moles, and then 10 NH3s. Okay, so that's our balanced equation. We want to figure out what is the molar mass of M. So we want to figure out grams M per mole M. We're going to figure these two things out separately. We want to figure out grams of M and moles of M separately. Now, we do know about nitrogen, and there's also hydrogen. We can actually use grams of N. If we knew how many grams of N there are here or here, because they're the same, we could then subtract from the total mass, which we have. We've got 50.32 grams and 9.550 grams. So because we know how many grams here, if we know how many grams of nitrogen, we could subtract and get grams of M. So let's go ahead and get started. So first, I'm going to find grams of N. Okay, then we're going to subtract. So I'm going to start with the thing I know, ammonia. I know everything about ammonia. I know nitrogen and hydrogen. So I have 9.550 grams of NH3. I'm starting with NH3 because I don't know what M is, and I know what NH3 is. So 1 mole is 17.03 grams NH3. Now I'm going to figure out how many moles of N. Again, we're trying to figure out grams of N, so I know there's 1 mole N for every 1 mole NH3. And then I'm going to change from moles of N to grams of N. So you've done this before many times. It's just that you maybe didn't think of starting with N. So that gives me 7.856 grams of N. Secondly, now I can subtract my grams of N because the grams of N in ammonia are the same as the grams of N here. There's only N here and here. So now I can figure out grams of M by subtracting. So I'm going to take 50.32 grams, that's what we started with, M3N5, and I'm going to subtract 7.856 grams of N. Again, I found the N from ammonia. And N on the right is all tied up in ammonia. There's no nitrogen anywhere else. All the nitrogen on the left is in this compound. So this N is the same in both places. That's why I can subtract it. All right, so this gives me 42.46 grams of my unknown metal. All right, so I'm halfway there. I've got my grams. So now I got to figure out moles of my metal. Okay? Now moles, you should be thinking mole ratio. I'm going to use a mole ratio, and I have a mole ratio right up here. So if I know how many grams of nitrogen and change to moles of nitrogen, I can use my mole ratio and get moles of my metal. So I'm going to start off with and there's different ways to do this. I could have started with this nitrogen. I'm actually going to start with with 9.550 grams of NH3. Okay, and then I'm going to take 1 mole NH3, 17.03 grams NH3. I know the mole ratio here of my metal to NH3. I could have also started with grams of nitrogen and used my mole ratio here, and I would have gotten the same answer. So I'm going to use 6 moles of my metal M, because it's by itself, to 10 moles NH3. That's going to give me 0.3365 moles of my metal M. Okay, so fourth is going to be my molar mass. Again, in this step, we wanted to isolate M. We needed a mole ratio with M in it. We could have used M to ammonia, or we could have used M to nitrogen. I chose ammonia. Okay, so the molar mass of M is going to be, we have our grams right here, 42.46 grams of M. And I have my moles. Those are equivalent. That's very important that these two things be equivalent, and they are. That's 0.3365 moles of M. I've got 4 sig figs. That gives me 126.2 grams per mole M. You can look that up on the periodic table and determine what metal it is.